Hi, I'm Mark Foster, professor in the Department of Polymer Science at the University of Akron. And my area of interest is interfaces and surfaces of polymers, which we study with a variety of techniques using X-rays and neutrons in particular. I became interested in teaching at a young age. In fact, I started grading papers and assisting my teacher in tutoring students when I was in the first grade. Two very early lessons that I recall growing up from my parents. The first, my father taught me to always observe carefully. One of his favorite sayings was, keep your eyes open and your mouth shut. So from him I learned to look carefully. He also taught me about drawing so that I could take something that I had seen, imagine the different spatial relationships in my mind, and then commit it to paper so that I could explain it or show it to someone else. And both of those skills have really stood me in good stead as a professor and a researcher. My mother, on the other hand, who was a teacher, taught me a lot about how to convey to others what I've learned, and she also encouraged me constantly to ask questions. So the influences from my two parents were really quite complementary. I enjoyed math and science in high school, and I had very good physics and chemistry teachers in particular. And those two individuals encouraged me to go on in college in an area where I would be able to use both my interest in math and my interest in science. So since I enjoyed a challenge, and at the time it seemed that chemical engineering was one of the more challenging disciplines at the university, I chose to study chemical engineering at Washington University in St. Louis. I had an inner conflict over whether to be a teacher or whether to be an engineer. And as I was an undergrad, I spent time tutoring students, and I also substitute taught as much as I could during breaks, both at the middle school level and in the high school level. And finally, at the end of about my junior year in college, I came to the conclusion that I would not go on to become a teacher at the secondary level. As I was finishing undergraduate school, I had difficulty deciding in which direction I should go. I interviewed with several companies. There were many opportunities at that time for chemical engineers, and I considered some attractive offers. I also interviewed with 3 graduate schools and was admitted. A seasoned personnel manager at one company that I interviewed with told me at the end of the day that he was not going to make me an offer. I was very disappointed, and I was affronted because he told me that I should definitely go to grad school. He said, you've got graduate school written all over you. And I couldn't imagine how someone who hardly knew me, despite the fact that he had 35 years of experience, could possibly tell me what would be best for my career. Well, looking back, I would say that it was a very helpful piece of advice, and it's played an important role in my career. Before I started graduate school, I spent a summer working at Exxon Research and Engineering in Baytown, Texas, working on a project involving turning coal into gas, the kind of gas that we burn in the stove in the kitchen. This project involved looking at the structure inside the coal to understand how it reacts. And it was related to my favorite subject in undergraduate school, which was reaction engineering. Reaction engineering is the study of how to control chemical reactions. And this project got me interested in interfaces because the coal is changed into gas at the interface. Now, interfaces can refer to any place where you have 2 materials coming together. In that case, it was a solid against gas, but it could also be one polymer against another polymer. When I went to graduate school, I continued on with this interest in coal gasification and studied a project using X-rays to see the structure of coal as it reacts. Now, these X-rays are the same X-rays that are used by a doctor to, for example, look at your broken arm. But I look at them as they come out of a material like coal, and from the way they come out of the material, I can tell about the structure inside the coal. Unfortunately, in the middle of my PhD studies, oil prices fell, and funding for research in how to turn coal into gas shriveled up. Now, at that time, it was still possible, if one had done well as a PhD student, to get a teaching position directly out of graduate school. And so I applied to over 50 schools looking for a teaching position. But only 2 schools were interested, and those were schools where historically coal research has been very important. But I wasn't particularly interested in going to either of those 2 states. So I decided to look further, and I talked to my thesis advisor about how I might use what I'd learned in chemical engineering in a new area. And he suggested, why not begin looking at materials, the area referred to as material science. So my wife and I ended up in Mainz, Germany, where I got a postdoctoral fellowship at the Max Planck Institute for Polymer Research. There I took up a project which involved also the use of X-rays, but with a brand new technique called X-ray reflectivity. In X-ray reflectivity, rather than shining the X-rays through the sample, we shine the X-rays on the surface of the sample and we watch what comes off, just as we would look at the visible light reflection from, say, a puddle of water or a shiny piece of metal. And by looking at the details of the reflectivity, I can understand what's going on inside the sample, underneath the surface. My wife and I found our time in Germany very satisfying personally. I could have made the decision to work in the Institute primarily in English, but my wife and I decided that we would try to speak German as much as possible, and that we would try to fit in with the German culture as much as we could. And that gave us a unique view of our home country, and we understood better how science is done there and how people live in another country. Now, it did cost me professionally. My technical progress was slower than it would have been if I had just done it in English, but I got to know people in a way that I would not have been able to if I had spoken mostly English. So we have many good friends in Germany and many good memories, and 2 of our children were born in Germany. From Germany, I came back to the United States, where I served first as a senior postdoctoral researcher at the University of Minnesota, learning more about neutron scattering, and then I came to the University of Akron, where I took a position as an assistant professor, and today I'm serving as a full professor in the department. I've enjoyed teaching a long time, and I see being a teacher as an important part of my identity. But I'm still enjoying a lot doing research as well, and learning about how the world works. So I'm both a teacher and a student. I travel with my students to do experiments at national user facilities that have very powerful sources of X-rays and neutrons. Neutrons are another type of radiation that can be used to study materials. Well, I'm hesitant to say that I can tell you what the best thing is about my research, but I can tell you some things that I do enjoy very much. One of them is that the experiments, although other people tend to think of them as being very dry and boring, sitting in a laboratory in a lab jacket, I find doing experiments quite exciting. In order to do an experiment with a powerful X-ray or neutron source, my students and I have to plan for months in advance. And we try to do the experiment elegantly, like a craftsman, someone who knows how to work very well with his hands and fashion something that's precisely made. It's also a little bit like doing performance art. We have one chance at the major X-ray or neutron source to get it right. So when it does go well and the experiment turns out right and we learn something brand new, we really feel a lot of excitement, even if it's 2 o'clock in the morning when the results come. Well, I have students that are involved in a number of different kinds of work. I have students who have gone on to do policy work in Washington. I have students who are currently teaching in community colleges where essentially all they do is teach. I also have a student who's getting ready to take a research position at a university outside the United States. I have students who have done research at national government labs. And I have many students who've worked in various kinds of industry, particularly in industries where adhesion is important, with companies like 3M, for example. Today, I would say there are many, many opportunities for young people who have learned about surfaces and interfaces, and I'll mention 2 broad areas where this is true. Work with water and energy. Both of these represent limited resources which we have to take good care of. And when I'm talking about energy here, and I'm speaking specifically or more particularly about fossil fuels. But both of those have to be stewarded. For example, with water, we very often use membrane processes to purify the water. Those membranes are made out of polymers. And the most important part of how a membrane works happens at the interface between the water and the polymer. In energy, in fuel cells, in photovoltaic materials, which are solar cells, in new lightweight batteries, all of those different types of devices or products involve challenges that we are trying to meet today using new polymers or configuring polymers in new ways. So actually the career opportunities are very promising for people with expertise in interfaces and surfaces of polymers. I have two pieces of advice from my experience. The first would be that it can be actually very helpful to have to learn multiple disciplines as you're developing your career path. It was very frustrating for me to have to leave reaction engineering, an area that I enjoyed very much, and move into materials science, and particularly to polymers. But I see now that I have a much broader view. I can bring insights to my research which I could not have if I had just stayed in the area of reaction engineering. And I know that when I meet a new problem in my research that requires me to learn material from a new subdiscipline, I can do that. A second piece of advice would be that sometimes old folks have great advice. At the time when this fellow who had 35 years of experience told me I should go to grad school, I felt that he really didn't know me well enough. But experience is worth a lot, and it's important to listen to people who have that experience in addition to talking to your friends of your own age.